Today's lesson 2.3 is on solving two-step equations. We're going to start off with our equation 5x plus 2 equals 27. The first thing we're going to do is step 1. We're going to isolate the term with the variable, which would be our 5 times x, or 5x. And then we're going to isolate that 5x by getting rid of plus 2, the opposite or the inverse of adding 2 is subtracting 2. So we're going to subtract 2 from both sides. So we end up with 5x is 25. 5x means 5 times x. So we're going to do the inverse and divide by 5 on both sides to isolate x. So we end up with x equals 5. The next thing we're going to do is check that answer and make sure it's correct. So we're going to substitute x equals 5 into the original problem. So in here for x, we're going to go ahead and put 5. And then we have plus 2 equals 27. Now, if this is the correct solution for x, these two sides should balance out. So 25 plus 2 is 27. And yes, they do indeed equal one another. So we know our answer is probably correct. Now we're going to go on to the next page. We're going to skip to this one in the middle here, and we're going to follow those same steps we just did. We're going to isolate 3a. Even though it's on the right-hand side of the equation, we're going to work this the same. We're going to get rid of minus 14 by adding 14 to both sides. So we end up with 18 equals 3a. Since it's 3 times a, we're going to divide each side by 3 to solve for a. So a equals 6. So let's go ahead and check that to make sure that's right. So we have 4 equals 3 times whatever a is. A is 6. And then we're going to subtract 14. So we have 4 equals 18 minus 14, which is 4. So we're going to end up with 4 equals 4, which is equal. So we know that solution is probably correct. On our next screen, we have a little bit of a change here. We're going to go ahead and do this problem in the green first. We're going to isolate the negative 4v. Don't forget when you box that variable to box the sign that's in front of the variable as well. So we need to get rid of 18. We're going to subtract both sides by 18. So we have negative 4v. 13 combined with negative 18 would be negative 5. And it's negative 4 times v, so we're going to divide both sides by negative 4 to isolate v. So we end up with 5 equals negative 5 over negative 4. Those double negatives make it a positive 5 fourths. And you can leave it improper as long as it's simplified. So we're going to try to check that and make sure it's right. So here's our check. 18 minus 4 times 5 fourths, because that's our solution for v, equals 13. Order of operations says we need to do our multiplication first. We can put this over 1. So we need to zoom in on this right here. We can cross cancel our 4's, so we end up with 5 over 1, which is 5. And 18 take away 5 does equal 13, so that checks out good. Okay, I'm going to select one of these to do, because they're all pretty much the same. We're going to do this one right here. We're still going to box that, even though it has a variable underneath. So we're going to add 2 to both sides. So we end up with 11, and then a over negative 5. So a divided by negative 5, the opposite of that would be to take it times negative 5. So a is going to give us negative 55. So let's check that and make sure that's correct. So I'm going to plug negative 55 in for a, divide that by negative 5, subtract 2, and hopefully that equals 9. Negative 55 divided by negative 5 is 11. Now if we subtract 2, we end up with 9. So 9 equals 9. That does check out. Okay, on our next screen, the big difference on the first 3 problems is that we now have a fraction in front of our variable. We're going to go ahead and do this blue one here. So we're going to isolate that term that has the variable. So we need to get rid of 8. So we're going to subtract 8 from both sides. So we have negative 3/8 k equals negative 4 combined with negative 8 would be negative 12. Now I want to try to isolate that k, and the easiest way to do that is to take this whole thing times its reciprocal. By doing that, it'll wipe it out, but I also have to take it times exactly the same thing over here. Whatever you do to one side of the equation is okay as long as you do the same thing to the other. This will cross cancel, and that's exactly why we do that, because we want to isolate k. So divide by 3. Divide by 3. So now we have negative 4 times negative 8, which is 32. So let's go ahead and check that. So we have 8 minus 3 times 32, because it says 3 times k up here. We're going to divide that by 8. So we have 8 minus, that would be 96 over 8. Equals negative 4. Now, of course, if you don't know what 96 divided by 8 is, you go off here to the side and work that out. That's what your extra space is for. And we end up with 12. So we have 8 take away 12 is equal to negative 4. And that does check out. Negative 4 equals negative 4. I want to show you a little trick on this one with the decimals. It's really going to be worked pretty much the same way. But one thing you can do to eliminate all of the decimals, our highest number of places after the decimal is 2. So if we slide every single one of these 2 to the right, you can do that as long as you do it to every term that's in your problem. But one thing you want to be careful, make sure you've done any distributive property first before you try this. So 2.5 moved over 2 spots is now 250. 0.45 moved over 2 is now 45, and 0.95 is now 95. So that already looks a little bit easier. We want to isolate that, get rid of our 45. So we end up with 250g equals 50. And then to isolate g, I'm going to divide both sides by 250. So g is going to equal 50 over 250. One thing I could do is divide each of these by 10, and that gets rid of zeros. So I end up with 5/25, which is also 1/5. Now, since I started with decimals, I probably want to end with decimals, so 1/5 would be the same thing as 0.2. And then we could plug that back in the original and find that that actually works. All right, so our next section is finding missing integers. Typo there. So if you think about it, when you have consecutive numbers, that's one right after the other. Like if you have 11, 12, 13, 14, 15, those are consecutive numbers, one right after the other. Now, if I said consecutive odd numbers, it would be this 11, then 13, and then 15. So let's look at what happens with those consecutive odd numbers. If we call, let's say that we didn't know, we were trying to figure out what the numbers were. So we might call this one n. Now, if you take this number and add 2 to that, you get the next odd number. And if you take that same value for n and add 4 to that, you get our third number. So wouldn't it be the same if we were doing that with evens? So if we had 12, 14, and then our next one over here would be 16, this would be n. This would be 2 more than that. This would be 4 more than that. So that shows us this. Whether you have consecutive even or odd numbers, the first one is n. And on this particular problem, we're finding 3 consecutive even integers whose sum is negative 42. So 3 consecutive evens. So the first one would be n, second one would be whatever n is plus 2, and our third one would be whatever n is plus 4. So here the problem is already written out for us. Now we're going to put together our like terms. So I have 3 n's added together, which makes 3n, and then plus 2 and plus 4, which would be plus 6. And now we just have a basic two-step problem. So we're going to get that 3n and put it in a box. So we need to get rid of plus 6, well minus 6. So we have 3n is negative 48. We divide both sides by 3. We end up with n is negative 16. So that basically means our first number and our missing set of 3 numbers is negative 16. Now if we take negative 16 and add 2 to that, negative 16 plus 2 is negative 14. And then if we take negative 16 and add 4 to that, we get negative 12. So there are our 3 consecutive even integers. Even though they're negative, they're still considered even numbers. Okay, so let's move on. If you have odd integers, you're going to set it up the same. So we're starting from scratch here. So I always put these so I remember when I'm done I have 3 spots I got to fill in. Sometimes they're going to ask you for 4 or 5. That way you can keep track. So if they're odd or even, the first one is n, second one will always be n plus 2, and the third one will always be n plus 4. And we have a sum of 17. So I'm going to add all of those parts together. And we know the sum is 117. So if I add all my n's together, I have 3. I'm going to subtract 6. So I have 3n is 111. So we're going to divide 111 by 3. So we go in there 3 times. Then we have 21. It's going to go into 21 7 times. So we end up with n equals 37. So we're going to put n in here as 37. We're going to add 2 to that. So our second odd number would be 39. And then we're going to take 37 and add 4, which will give us 41. So all of those added together would give us a sum of 117. So that's your final answer. Now, sometimes you don't have odd or even, like right here, it just says 4 consecutive integers. So I'm going to put 4 dashes, so I know when I'm done I should have 4 values. So this would be n. Now, if they're consecutive numbers like 16, 17, 18, there's no odd or even that we're worried about. This would be n. This next one would be whatever n is plus 1. The third one would be n plus 2, and then as you can guess, the fourth one would be n plus 3. So we have n plus 1, n plus 2, n plus 3. For the sake of saving time, I'm going to go ahead and I have to have the sum of these, so I'm going to put a plus in between each of these parts. And my total should end up being 94. Right here, sum of 94. So I have n plus n plus n plus n. So that's 4n plus 6 equals 94. I'm going to subtract 6 from both sides. I end up with 4n is 88. N is 22.